Welcome back to Cubstart iOS Lecture 2, and today we will cover more Swift and introduce SwiftUI fundamentals. And quick announcements. Homework 1 is due tonight at 11:59 p.m. and feel free to ask questions on ad if you need any help. And homework 2 will be released today after the lecture. And here's the plan for today. We'll go through optionals, object-oriented programming, structs versus classes, and later we'll move into Swift UI. The goal is to make the Swift side feel solid before we get deeper into UI, and we will call it a day. Let's start by connecting optionals back to something we may already seen, enums. And enum is just a type with a fixed set of cases, so it's useful whenever something naturally falls into a small number of discrete possibilities. For example, here, for matter states, we have solid, liquid, gas, and plasma, and for direction, we have left, right, up, down. That's the key idea we need because optionals are built on exactly that pattern. So, what are they? Optionals are really just enums with two cases. There is a value or there is no value. In Swift, the no value case is written as nil. It's the same thing as none in Python and uh, null in Java. When you put a question mark after a type like string, question mark, you are saying this value might hold a real string or it might hold nothing. A useful way to think about an optional is like a box or a present. The outer thing is still an optional int, and what's inside might be an int or might be nothing. In this first example, the wrap value is nil, so the box exists, but there's nothing inside of it. Now, if we assign 5 to an optional int and try to add 10 directly to it, and Xcode will complain. The reason is not that 5 is bad, it's that SwiftUI sees the value as optional int, not plain int. So arithmetic works on real ints, so before we do anything with the value, we have to unwrap it. Once we unwrap the optional, we get back to the plain int inside that unwrapped value is no longer wrapped in optional, so now we can behave like a normal integer. This this distinction matters a lot in Swift because the language is very explicit about when a value may or may not exist. One the first safe way to work with optionals is optional binding, usually with if let. What this does is check whether the optional actually has a value, and if it does, Swift unwraps it and binds it to a new value inside that if block. You can safely use the unwrapped value at like a normal value. Another common pattern is optional chaining. This is what you use when you want to call a method or access a property on something that might be a nil. If the value exists, Swift keeps going. If it's nil, Swift just stops safely instead of crashing. And the nil coalescing operator gives you a default value when the optional is nil. So if the thing on the left exists, Swift uses it. Otherwise, it falls back to the value on the right. This is really nice um, when you want a clean default instead of writing a whole if else. So force and rapid means using an exclamation mark to pull the value out directly. You should only do this when you are completely sure the the optional is not nil. If you're wrong, your app crashes at runtime. So this is one that looks convenient but can burn you very fast. And guard is another really important Swift pattern. You can think of it like a gate at the beginning of a scope. If this condition is satisfied, execution continues. If not, you exit early. It's often clearer than just a deeply nested if else because it keeps the main logic moving straight down the page. So that was the main optional section. The big idea is that optionals let Swift represent the possibility of missing data explicitly, and then the language gives you several ways to handle that safely, depending on the situation. Now we are going to shift from missing values to modeling data in a bigger way. In other words, instead of asking does the value exist, we're now asking like how should we represent real things in code? So object-oriented programming is programming elements where we organize code around objects that bundle data and behavior together. You should be pretty familiar with it if you have taken some lower division CS classes. Um, the reason people use it is that it makes code more modular, more reusable, and usually easier to maintain once programs gets larger. So let's say we want to model a person. A person has things like a name, age, occupation, and favorite color. If we use separate variables, that works for one person, but it gets messy really fast if once we want to represent many people constantly. So this is where structs comes in Swift. Struct lets us package related properties together into one coherent type. So you can think of the type like a blueprint. It describes that what a person is supposed to contain, but it is not yet a specific person until you create an instance from it. So once we have the blueprint, we can in instantiate a real object from it. That means making concrete people like Kaylee and Robert, each with their own values, same structures, different data. So these are instances or objects of the person type. The important idea is that the struct defines the shape and each instance fills in actual values for that shape, then we can use those objects directly into our in our code instead of managing loose variables everywhere. But there is also classes. At this point, you might think, okay, I've heard about classes too. That's exactly the next question because in Swift, both structs and classes can model objects, but they behave differently in an important way. So now we're done with basic OOP motivations. Next, we will compare two main tools Swift gives us for building these data models, structs, and classes. This part matters a lot. In practice, one of the biggest Swift decision is whether something should be a struct or a class, because that choice affects how data moves through our program. So here's here we are setting up the comparison using the same person example. That makes it easier to isolate the real differences because the data itself stays the same while the underlying semantics changes. First, structs and classes have a lot in common. Both can store properties, define methods, use scripts, have initializer be extended and conform to protocols. So the difference is not one can do everything and the others can't. The real difference is in behavior and semantic. So they both can define properties to store values and define methods to provide functionality, define subscripts to provide access to the values using subscript syntax, and also define initializers. But they can also be extended to expand their functionality and also conform to protocols. And but like classes in addition can have um, some extra capabilities. They support inheritance, type casting, uh, deinitializer, and also AR, ARC, reference counting, which is automatic reference counting. You do not have to master all of those today, but you should know that classes come with more machinery and therefore more overhead. And here are some differences that matter most right now. So structs get a default member-wise initializer, while classes do not. More importantly, structs uh, have values assigned to a variable or passed to a function, and that's the instantiation you really want to remember. And here's this, and for pointers, not really, like not direct pointers to an address in memory. So here's the same person model written as a class. Notice that for this class, we explicitly write an initializer. That's already one small sign that classes are a bit heavier than structs. And here is a struct example. When you assign a struct instance to a new variable, Swift treats that as making a separate value. So if you change the copy, the original stays the same. And here is another class example. Classes work differently because they're reference semantics. When you assign class instance to another variable, you are not making a new independent object. You are creating another reference to the same underlying object. So mutating through one name affects that what the other name sees too. And this visualization shows the original struct instance by itself at this point. There is only one value, so nothing surprising is happening yet. The interesting part comes when we assign it somewhere else. So after assignment, the struct produces a separate copy. That means if one copy changes occupation to accountant, the other can still remain singer. Conceptually, there are now two distinct values. Now compare that with the class version. After assignment, both variable names refer to the same name underlying object. So even though there are two names in the code, there is still just one actual instance being shared. That's why when one reference updates the occupation, the other one appears to change too. It is not because with copy the new value over to both. It's because both names were pointing at the same object all along, and that's really the core difference between structs and classes. And now Justin will introduce SwiftUI basics. Let me stop sharing.
Cool. Thank you, Abby. Um, cool. So now I want to talk about SwiftUI. Now, we talked for last lecture and then for today's lecture, the first half, we covered the fundamentals about Swift, which is the programming language of how we can write logic, how we can structure data, and control the data flow as well. So now I want to talk about how to actually create UI. So just a recap of how we build iOS apps, SwiftUI is a UI framework and it's a declarative framework. So that means is that you simply state what your UI should do. And to create more complex views, you composite them, you compose more complex views from smaller, more simpler views. And it's cross-platform. So that means that you can have a single code base that targets all of Apple's platforms. And so we use Swift. So for example, we might use the if statement with some condition, and we're able to control whether a view should appear or disappear, and etc. So there historically, or as of right now, there's two ways you could write UI or build UI. There's two main frameworks. One of them is called, of course, SwiftUI, which is the one that we're going to be learning. But historically, there's always been another framework called UIKit. Now, UIKit has been available since iOS 2. So basically, since the very beginning of iPhone. And UIKit is a very object-oriented kind of framework. So it's not declarative. It's imperative. So what that means is that you create instances of your objects. For example, here you would create an instance of a UI button. And then on this instance, you might call different methods, set properties to configure this button. And the view themselves are all layered with subviews. So it's very, again, very object-oriented heavy. And what that implies is that it's very step by step. So you have to, call this method, you have to set this property, and then you call this method again. So it's very manual. Whereas if we compare it to SwiftUI, relatively the same piece of code or kind of code that we want to kind of convey, this is what it looks like in SwiftUI. So SwiftUI is, as you can see, what we're saying here is that, hey, we want to have a button. What does this button look like? And what happens when we click on this button? So it's very simple. We simply state what we want, and SwiftUI does a lot of the heavy lifting for us. So the critical thing about SwiftUI is understanding that a view defines a piece of UI. So what that means is that a SwiftUI view configures and is a piece of UI, and vice versa. UI that you see on the screen is a SwiftUI view. So what do I mean by SwiftUI views? So Apple gives us some fundamental building blocks, so fundamental views. For example, a text to show some text on the screen. If you want to show an image, there's image, buttons, text fields, shapes, and so much more. So we use these kind of primitive views, and to create more complex views, we can compose them together to create views that are more custom to what we want. So how do we compose these more complex views? Well, in addition to views, we also have these kind of containers that SwiftUI has. So for example, let's say I want to lay out a couple or two views horizontally to create more bigger view. What we would use is something called an H stack. An H stack simply wraps its subviews into a container and aligns them or lays it out horizontally. So it lays its subviews horizontally. Now we could say the same thing for vertically. So we use a V stack instead. So now I'm basically copying pasting what we had before, our H stack. So we have two H stacks, and to compose them vertically, we use a V stack. Now, there's one more dimension that we're missing, which is the Z axis, which is the axis that is basically pointing from your monitor to you and into the screen itself. So the Z stack layers its objects on that plane. And you can think of it as like Photoshop layers. Now, of course, now we know that we can create more complex views together using SwiftUI's more primitive views and together with containers like HStack, VStack, and ZStack. Now, our UI, if we just had these kind of tools, our UI would look very plain and boring. So how do we kind of change how the views look? For example, let's say I want to change the color, a text color. So here's how we would create a text view in SwiftUI. We'll simply create a text view, and then inside we'll just pass in the string that we want, in this case, hello. Now, if I want to change the text color, we can use something called a view modifier. A view modifier simply augments the current view and generates a new view. So in this case, first we tacked on this foreground style view modifier, and we passed in the color that we want, which is color.blue. What happens then is that it generates a new view with the applied foreground style view modifier. Then on this new view that we generated or created, we apply another view modifier, which is called bold. And that simply sets the font weight of the text to one of bold, to bold. And so now you can see that the color is blue now and it's bolded like so. And again, the thing that you want to understand is that each of these view modifiers that you apply creates a new view. So it basically augments the current one and then generates a new view out to the display. So that was sort of a quick look into the fundamentals and building blocks of SwiftUI. Now let's move on to a demo where we'll create a custom view from scratch and applying these kind of ideas that we talked about. So the demo that we're going to do is that we are going to recreate this view. Now this view can be found in the GitHub iOS app. So if you go to any repository, this is sort of the repository header of that repository. And as you can see, it has quite a bit of components, right? We have this kind of header where we have the logo of the repository, we have the name of the repository or the organization, and then we have the repository name, we have description repository, we have the link to this repository, we have the number of stars, number of forks, and we have these two buttons. And again, there's a lot going on. There's images, there's these symbols, there's buttons, there's text with different colors and different font weights. So we want to see how we can build something using the primitive building blocks that we mentioned that Apple gives us in SwiftUI, and how we can use those view modifiers to change how those basic items look to what we want, as we see here. And here is a full link to the GitHub gist so that you can view all of the completed code later on. All right, so let's take a look. So here we have, oh, sorry. Here we have, I spun up Xcode, and just to give you a quick tour of Xcode. So right here in the middle is your code editor. And it's basically, again, where you edit, add, change code. To make the text of the code editor larger, you could press Command plus. To make it smaller, you could do Command minus. And then here on the left, we have the sidebar. The sidebar has a lot of functionalities. One of them, the most leftmost one, is our file navigator, and this is where you can see all of your files. The second one is called source control, and this is where if you use Git and GitHub, this is where all of your remotes, all of your changes will show up here. Here we have this bookmarks tab. And what that simply is that, for example, let's say I have a piece of code here that I want to revisit later on. I could right click this piece of selected code, and then I can click on bookmark. And what that does is that it bookmarks that line of code, and you can also bookmark files if you want, and it just shows up here. So this is sort of like a to-do list thing that you can keep track of things you want to go back to. Here is probably the second most frequently used tab, and this is the search. So for example, I could search for specific lines of code. You can change, customize what kind of search query that you want to have. You can also click here to kind of target a specific file or specific section in your code base. The next one is your issues navigator. And this one right here is when you actually compile the app. And if there's, for example, some kind of compilation errors, it will show up here. This one, you could ignore it. This is for our test cases. This one is called the debug navigator. And this is when we're actually running the project itself, the running the app. And here you could see different, when we run it, I'll come back to this, but when we run it, you could see different metrics like how much CPU we're using, how much memory, how much energy we're using. And also, if you're a bit more tech savvy, you could also see a whole list of all of the threads that are happening. Here, the second to last navigator is called a breakpoints navigator, and what a breakpoint is that simply on here in the line number gutter, you can select on one of these numbers, and you can see this kind of breakpoints appear. What that means is that when you run the app and when it hits that line of code, it pauses execution, and you underneath here you can see a console appears, and you can see and analyze all of the variables within that context. And then finally, right here in the last one is the builds navigator. And this is when you're actually running the project. You can see logs of what went wrong, what went right, and so forth. Okay, so here is our code. And as you can see here, what this code does is that we're importing SwiftUI, which is the framework that we could actually use SwiftUI. And then here we have a struct. And this struct is called content view. And you can see here we have this colon and this view. What Vue really is, it's a protocol. So what a protocol is, it's simply like a sort of like a law. And in this protocol has a list of requirements. So one of these requirements is this body variable. So what this protocol view, any struct can conform or become this view. So any struct can say, hey, I'm a view. Now the view has that requirement, right? Has a list of requirements. One of them is this body. So whatever, if I delete this, Xcode is going to complain because it's going to say, hey, content view wants to be view, but one of its requirement is missing. What is that requirement? That is this body variable. And so we have to uh have this body variable. Now this body variable is of type sum view. Now I'm not going to go into details of what this does, but what it does is that within this body you could have many different types. You could have text, you could have images, you could have stacks like what we right now. And so what the sum view does is that the sum keyword basically wraps this whole whatever you have within here and just more kind of opaque object type that SwiftUI can deal with. Again, don't worry about it too much, but it's something that you need to do. So within here, we can see a VStack. We have an image. Now, this image is not a regular image. Now, it's not like an asset that I imported into this project. What this image is something called an SF symbol. Now, you can download this SF symbols app from the apple.developer.com website. And this app has a bunch of symbols that Apple specifically hand created, and you could use them for free. And it's really simple to use them within your projects. So, for example, let's say in this case we have globe. You can search for the globe, anything that matches that globe. You can right click on that symbol and you can say copy name. And then to basically use that symbol, we use the image view. And then we simply pass in the name of that SF symbol, and then we can render it. Now here you can see we have, by default, it has these two view modifiers being applied. One of them is the image scale, one of them is the tint of the globe. And so what we want to see is this VStack will lay out these two subviews vertically, and then we're going to wrap this VStack with some padding. Now, how do I see it? Well, I can actually run the app by clicking this play button in the top left corner in the right corner of the sidebar. But we also see we have this preview thing down below. Now, this preview is something called a macro, and whatever you put in here is being shown in the SwiftUI canvas. So I can access this canvas by simply going to the upper right-hand corner here. And here I can click on it, and if I go down to canvas, you can see that we have a sort of like a simulator, like an iPhone. And what's being shown here is basically what's being provided within this preview macro. And this is just for development purposes. We're not going to be using this. This is not going to be part of our app when I actually run the app. It's just for us to iterate upon to help us accelerate development. Okay, so let's kind of start and talk about how we can implement this from scratch. So the way I like to kind of think about UI is that we see here, right? Think about each of these containers, right? These H stacks, V stacks as rectangular bounding boxes, these bounds. And so when I look at this, I see a lot of things, right? Layered vertically. So I see this section right here, right? This header. I see this right here. I see this description. And then below that, I see this link. Below that, I see this one right here, all the stars and forks. And then finally, I see the buttons. Now, if we just analyze the stars and forks, right? If you think about this as the bounding box, within here, I can actually subdivide it even more. where and within this row, I have another box on the left, I have another box on the right, and then within each of those boxes, I have an image, right? This ESTA symbol. Then I have this you know the string right here, right? So I could see that we have different, we could go down and drill deeper, deeper, deeper. But the important thing is kind of think high level and see what boxes that you could identify and how are they arranged. So obviously I know that I need a VStack to contain everything. And let's kind of target the first thing, which is I want to create this row that we see right here. Now, okay, so what I need is this Swift image logo. Now, I've actually imported or downloaded this logo and I've dragged it and dropped into this assets file. This file is a special file, which basically we can use them within our project. So this image is called Swift-OG. And then we'll go back to the content view, and then I'm gonna use that asset. So what I'm gonna do is I'm gonna do image system, sorry, not system name anymore because that's not a SF symbol, but we're gonna actually use the name of the asset itself, which is Swift OG. And as you can see on the iPhone, you can see that the image is there, but it's really, really, really big. So how do we make it smaller? And the first step we could do is that we could use this resizable view modifier that allows us to kind of resize that image. And then we could set a frame to specify the width and height. So I could say I want this image to be of width 25 points. Now, these numbers are not pixels. They're called points. And the reason is because different devices have different resolutions. So you cannot say, 25 pixels on an iPhone, iPhone with a Retina display might look very different from one that's not. Or maybe, there's more resolutions, right? Phones with more high resolution. So that 25 pixels is gonna look mean very differently from different device. So what this 25 is we're using this points kind of coordinate system where it's the same for whatever device that you're running on. So then I'm going to set the same thing with the height to 25 points. So now you can see that we have resized this image into 25 points to 25 points. Now, I don't know if you can see here, but here in the slides, it's like a rounded corner. To create this rounded corner effect, we'd use another view modifier called clip shape, which you specify a shape that you want to clip the original view into. You can think about this clip shape as like a cookie cutter. You just basically specify what kind of cookie cutter shape you want, and it will stamp that original image or whatever view that you're trying to apply this movie modifier onto, and it's going to stamp it out. So the shape that we want to be our cookie cutter is our rounded rectangle shape with a corner radius of 8. So now if you see here, our image now has a rounded corner, which is what we want. All right, so now let's do this text. Now I can see that this text is to the right of this image. What that means is that we want an H stack that contains our image and our text. So I'm going to put this image in our H stack and also this text. Now this text is gray, so I'm going to set the text color. How do you do that? Use this foreground style view modifier. I'm going to set this to the color gray. And then I also want to specify custom font size. To do that, I can use the font view modifier, and I can use a system font of size 17. So now our text is gray and it's of font size 17. This is great. So now we have done that. Now, right now everything is centered because by default VStack lays its subviews centered. We want to align everything to the left. So VStack actually takes another argument called alignment. And this alignment, I can say I want it to align to the left by using this dot leading. Now, right now, you can't see much of it. The reason is because now if we apply like a background color to this V stack, so let's say I want this to be red. You could see that the bounds of this image or this H stack only takes up this width, but we want to kind of expand and fill everything. So one way we could do this is by applying another another view called a spacer to this H stack. And what that's going to do is that it's going to take up the any available space that we have and it's going to put it into here. So now our H stack now has all the text and image is being pushed to the left, and all the available space that we have is now being sent to the spacer. Okay, so now let us create this Swift text view. So here, again, I'm just gonna do another text. This is Swift. I'm gonna make this bold. I'm gonna make the font of title. And then let's do this kind of description, just pretty straightforward again. I'm gonna do text, the uh, the Swift, the Swift programming language. Right. Okay. So there we go. We can see that we have the Swift programming language and we have the Swift, bolded Swift text. Now, you can see that we have some space between Swift and like between the top of the Swift programming language and the bottom. And we can actually specify the spacing that we have in this VStack using another argument here. And I'm going to say 15 points. So that gives us some spacing within this VStack. Nice. All right. So now let's go down and let's complete this one right here. So again, I can identify that this has two things. It has this link as a symbol, and we have this text. How are they aligned? They're aligned horizontally. So what that means is that needs an H stack. So we use an H stack, and we're gonna have this image, the system name, the S symbol name. I already found it. This is called link. And we're going to apply a foreground style of gray. And then here we have this text swift.org. And now I'm remove this padding of background color. Nice. All right, so now you can see our body is getting a bit cluttered. And again, this is not good. Your body should be very lean in the sense that when you kind of glance over this body, you kind of have an idea of what's going on. But right now, it's like there's a lot of overload that I need to understand, right? I need to figure, okay, this is this is the header kind of view. So what's great about this is that we can kind of abstract or refactor this so that this is a variable. So I'm going to take the header view. I'm going to create a private variable that's only accessible within content view. I'm going to call this logo header, and it needs to be type of some view, like the body. And then I could reference this logo header in the body itself, in this VStack. Let's give it a second. Maybe we can reload this. There we go. So as you can see that now, it's again, same thing, but now our VStack looks more, if I look at this, I don't have all this kind of, bombarded to my eyes, right? I can see, okay, this is logo header. Now let's do the same thing for this. And I'm going to call this main view. Now this main view gives us an error. And the reason is because we can't have like separate subviews by its own on the same level within this variable, right? This. So what one of the ways we could resolve this is like wrap it in another VStack. But what we could use is that we could tell SwiftUI to kind of build this view from scratch, kind of, and we could use um, this property wrapper called View Builder that again, you don't need to know the exact details of how View Builder actually works, but it's just gonna construct this view if you have separate like views, subviews, on the same kind of level, without anything containing itself. So just gonna wrap it and it's gonna do its own thing. So this is one of the ways that you could mitigate, to fix this issue. And then I'm gonna reference main view under logo header. So there we go. There we go. Now let's kind of do these two things right here. Let's just first work on the stars portion. So here I am going to again, it's the same thing with the link where we have a H stack. So I'm gonna do an H stack and I'm gonna do an image system name. I think this one is of type star. And then here, we're gonna have some font weight of medium. And then here we have the stat, we have 67.3K. And this one is font weight of medium. And then here we have foreground style black. And then finally we have stars. And this one, yeah, just leave it as it is. Okay. So as you can see here, actually this one's kind of a grayish color, so I'll set this to gray. So, okay, we did this for, and also this one's gray as well. Okay, there we go. So nice. So let's do the same thing. And then this one is for the uh, forks. I couldn't find the exact same icon as what they had, but I think there's a similar one called arrow, triangle, branch. Then I do 10.3K and forks. Now, these guys needs to be an H stack that contains both of them. Boom. All right, so now this is getting a okay. Now we see that it works, but we basically copied and pasted these two pieces of code, which is when that happens, alarm bells should ring up because that is not good code. Because what if we want like 100 of them, right, or a lot more? They have to copy and paste the same thing over and over again. What we could do is that we could refactor this into its own struct. So what we could do is that I'm going to basically cut this out, and then below here I'm going to create our own custom struct, which is called repo stat view. And in here I'm going to copy and paste. Now we want the system name, this uh the stat number and the stat name to be variable, right? We want to like kind of give those information into repo stat view. How do we expose that? We can set properties on repo stat view, and then on creation, we could just basically pass it in, which is so convenient. So here we have stat name, and then here, instead of star, I could do system name. I could do stat number. Oops. And then I could do stat name. So now I've created my custom view, right, from these SwiftUI building blocks, and then I could use it up here. So I could do repo stat view. And then what is the system name? Well, that one is stars. And then here is the 67.3K. Here is stars. And then I could just basically, instead of replacing this another H stack, for the forks. So I could do arrow.triangle.branch and then 10.3K and forks. So there we have it. So you can see the view themselves, it's the same thing as before, but we refactored that uh, repetitive code into its own view that we could reuse and simply pass in whatever properties that we want, and we could vary it. So that is super useful. All right, so finally, let's target this star button. Now, how a button works is it has two parts. It has this action part and it has the content of what this button actually looks like. Now, just for time's sake, I'm going to kind of copy and paste what this button looks like into here. And if you take a look at the code, you can see that it's what we're doing here is that we have a HStack. It has the image of the star, it has the text right here. Now we want to center it, so we're gonna basically use spacers on both ends to take up all of the available space, right? And then we're gonna divide it into those two spacers. We're gonna do some kind of additional view appearance modifications using these view modifiers. And then to create this rounded rectangle effect, what we could do is that we can add an overlay on top of this view. And here we have this kind of rounded rectangle shape with a stroke modifier to modify the border of the rounded rectangle. And then here within this button action, this kind of in these curly braces, that gets ran whenever this button gets pressed. So I could, have a print statement here. And then when I click on this button, now make sure that you're selected with this on the leftmost selection here. This allows you to actually click on or interact with elements in the canvas. So when I click here, you can see in the console we're printing star out, which is really cool. Now I'm going to do the same thing. Now you could do the same thing for the this bell icon, right? And you can add it here in another HStack. But since we're not running out of time, hopefully this kind of gives you of how we can create more complex UIs with simpler, smaller ones, and using those VStacks, HStacks to kind of compose them together and style these views to however we want using view modifiers. So, like I mentioned before, SS Symbols is this app that you can download from this link right here. And they're Apple crafted icons that you can use right away within your apps. And using them is really nice because it provides a sense of consistency and familiarity to your users because other apps probably use them and also the operating system uses them as well. And they're very customizable. So you could customize the font weights, you could customize the colors. There's certain animations or simple effects that you could also apply to them. So that wraps up today's lecture. So in today's lecture, we first talked about a really powerful feature of Swift, which is called optionals, that allow us to represent something as there's no value at this variable, right? This type can have some value or it does not have some value, and we can work with these optional types with a variety of techniques, optional binding, which is basically safely accessing this optional using an if else style syntax. We have optional chaining, which is basically trying to safely access a property of an optional. We have no coalescing operator, which allows us to specify a default value to this optional if it's nil. And in some cases, we can basically tell Swift to get the value no matter what using force unwrapping with the exclamation mark syntax. So we've seen how Swift, right, is a programming language, and we could use write logic and represent data models using structs and classes. And we have seen how we could create views using SwiftUI. And we can create more complex views using composition, using HStack, VStack, ZStacks. and we can change how those views look using view modifiers that can apply to them. Yeah, so that is it for today's lecture. Thank you for coming, and we'll catch you guys up in the next one.